Hello, welcome to the video. In this lesson, we're going to be looking at section 6.6, where we're going to be looking at inequalities in two triangles. So the question that they pose to us, it says, if two sides of one triangle are congruent to two sides of another triangle, what can we say about the third side of the triangles? Well, there's a couple things. One, we have what is called a Hinge theorem, stating that if two sides of two triangles are equal to each other, so in this case, they're saying that uh, Vx is congruent to RT and VW is congruent to RS, but with also within that, between it, we have two different uh, interior angles between the two congruent sides. So what they're saying is that since this is 88 and this is 35, the conclusion that we can make is that the opposite side here, WX, is actually going to be greater than the opposite of this angle, ST. Okay, kind of similar, but the same idea of when you looked at one triangle, the largest angle was opposite of the longest leg, kind of with that same concept in mind. Here it's saying that if you have, two congruent sides, the third, if it's different measurements, like it is here, AB is 12 and DE is 9, the conclusion we make is, oh, the opposite angle here is going to come into play, and since 12 is greater than 9, that means the opposite angle C is actually going to be greater than the opposite angle of F. All right, so using those theorems to help us out, what we're going to look at is we have two triangles, and it says that ST is congruent to PR. Both triangles share uh, PS because of the reflexive property. But we have RS is 23 and PT is 24, which are different measurements. So the question is how do we compare angle uh, PST? So PST is right here, and SPR. So SPR is right there. So since 24 is larger than 23, what we can say is that uh, the measurement of angle PST is actually going to be greater than the measurement of angle uh, SPR. Over here, it says that given JK is congruent to LK, we have two measurements here in degrees. One is 64 degrees, one is 61. How does JM and M or LM compare? Well, since 64 is greater than 61, I'm going to say that JM is going to be greater than LM. And then finally here it says they want us to write an indirect proof of the converse of the Hinge theorem. So since they give us AB is congruent to DE and BC is congruent to EF, they're also telling us that AC is greater than DF. They want us to prove that the measurement of angle B is greater than the measurement of angle E. So since they want us to do an indirect proof, what we're going to do first is we're going to temporarily assume that angle B is not greater than angle E. So we're going to we're going to try to contradict our temporary assumption. So if that's the case, that means that it could be one of two things. It either can mean that angle B is greater than angle E, or sorry, angle B is less than angle E, or angle B is equal to angle E. One of the two. So if we go with the first assumption, less than, then we'd have to say that then AC would be less than DF, which we know is not true. So that won't work. And then if B is equal to E, then like this would be equal and this would be equal. That would mean that triangle ABC would be congruent to triangle DEF due to side angle side. And because of corresponding parts of congruent triangles are congruent, then I would say that AC would be then equal to DF, which, again, from our given statement is also not true. So, by contradiction, given that AC is greater than DF, that means the measurement of angle B must be greater than the measurement of angle E. And that is being able to look at inequalities in two triangles. I hope this helps. Until next time.